Alright, moving on to the exponential functions and their asymptotes. So, looking at each of these, there is some horizontal or vertical line that they're not going to be crossing, but they do get infinitely close to, and that's called a asymptote. So if you look at one here, your function gets really, really close to this red line here going left. But it's not going to cross it. And so that is going to be our horizontal asymptote. And we need to write down what that function is, what the value is. That is the function, the equation of y equals 2. Because right here, all the y values are 2. And so that's the equation for the line there. Moving on to 2, and I'm going to switch colors in hopes that it'll be easier to see. Yeah, that should be better. Okay, this new graph here has a horizontal line that it gets really, really close to, but it's never actually going to cross. And so I have a horizontal asymptote here, and that has an equation of y equals -2, because it's down 2 from the x-axis. Moving on to 3, this one's got a horizontal asymptote here at a y value of 4, and so that guy has the equation of y equals not 5, 4. And so there's 1 through 3. Moving on to 4, these ones have a vertical asymptote, and this guy is looking like it's right there. It's getting really, really close to that line, but it's not going to cross. And that is the line of not y, but x equals a number, and it's the x value over here of -5. So that one's going to be x equals -5. Moving on to number 5, this one has a vertical asymptote here right at the y-axis. And the equation for the y-axis is x equals 0, because all the x values there are 0. Moving on to 6, this is going to have a vertical asymptote here, which is the x value of 4, and that's it for the equation, just x equals 4. All the y values can change, and we just have to have x be 4. And we need to move on to the back side. I'll get to that in just a second. Alright, continuing on with our lovely assignment here about asymptotes. Here, on this first part, you need to fill in the table for the function of y equals 2 to the x power. And you just do this like we did with old exponentials. You take the x value, put it in for x, and then calculate, you'll get your function value there. And let's start with the positive ones, just so we can get those out of the way, and those ones are quicker. I'll talk about the negative ones real quick, give you a quick reminder. If you put 0 in for x, anything to the 0 power is 1. If you put 1 in for x, you got 2 to the first power, which is 2. Now you do 2 to the second power, which is 4. That's 2 times 2. 2 to the third power is 2 times 2 times 2, which is 8. When you put in negatives, you need to do 1 over that 2 to the positive version of the power. So that one's going to be 1 over 2. This one's going to get 1 over 2 squared, which is 4. So 1/4. And the next one, 1 over 2 to the third. We already did that. It's 8. So it's going to be 1 over 8. Okay, so negative exponents give you fraction function values, y values out of there, okay? So once you have all these points, you can plot them down on your beautiful graph here. We got 0, 1, 1, 2, 2, 4, 3, 8, 1, 2, 3, up there like that. And as you get left, as you go left, you're gonna have to make your best guess on where the points are really, really close to the line here, and so you just have to make your best guess on those. But when you connect them up, you're gonna get look like this, and our graph's just gonna get really, really close to the x-axis there. Okay, now you got that, you can determine the current horizontal asymptote. Well, it's right there. It's not going to cross that line, and that is the line y equals 0. And when you determine the new horizontal asymptote, if we shifted everything vertically 2 points, well, if you take everything and you go up 2, your new vertical asymptote is going to be y equal 2. Because it used to be here, and if you move everything up 2 points, that's going to be your new horizontal asymptote. Moving on to 8 and 9, you have a function here, which we kind of just did, except instead of adding 2 on the end, this one's add 3. And so even though this one has been, this one got shifted up 3 points, so it currently has a vertical asymptote of 3. When you translate it vertically, 2 more points, and so if you got 3 plus the 2, you're going to get a new horizontal asymptote of y equals 5. Okay. When you read this and circle the right answer for an exponential function of f of x equals a to the x plus or minus k, we conclude that the horizontal asymptote given by the value of, well, this here, that's just the function, like the original one, like 2 to the x. That actually didn't determine our horizontal asymptote. It was all in what got added on the end. And so k is going to determine our horizontal asymptote. And so if you got a function like this, right now has a horizontal asymptote of positive 3, and you shift it down 2 units, you're going to have 3 minus 2 being 1. Our horizontal asymptote is going to be y equal 1. And that side's done.